Nate, what's SSH?
We touched on this SSH. Well, if you go back far enough, we used to manage remote systems using open protocols like Telnet and FTP, which were always a bad idea, but it's what we had at the time, right? And the problem with those utilities is that if you had a bad actor that was able to get anywhere in the stream between your source and destination, they could sniff packets and they could reassemble them into whatever your session was and pull out things like sensitive data, such as username, password, and the destination that you were connecting to. Very bad stuff because now they have your username and password and can connect to the same system that you were on. So back in the late 90s, I think it was, SSH replaced Telnet with the way in which you would connect to a system. Now, Telnet was still around for a little while, but it was very discouraged. So you'd have an SSH server on your server, and you would connect to it, and it does this key exchange, and you end up with an encrypted tunnel between the client and the server. And then your entire session, which looks very similar to how it used to in the Telnet days, is now encrypted, so people can't actually read that data. That's essentially what SSH is. You got anything to add there, Scott?
I started using SSH in like 1997, 1996.
Something like that.
And that's kind of when it started. There have been several machinations of the encryption technology used to back SSH. So earlier versions of SSH, like back from the 90s, are not really considered secure anymore because the cryptography algorithms used there can be captured and the encrypted content can be decrypted. Just like DES3 and some other older algorithms.
Yeah. I mean, this is as technology marches forward, encryption has to march forward as well, is really what it comes down to. Because usually encryption, it's not necessarily foolproof. There's always ways to reverse encryption, but it becomes like diminishing returns, right? You don't have a machine fast enough to decrypt on the fly or even decrypt post, right? Because it'll take you years to get through it and decrypt it, and by the time you've decrypted it, the information is useless. But as machines get faster, or as machine architectures change, or as we get GPUs, or there's all this conversation around quantum computing, we'll probably have a lot of changes in encryption when quantum becomes a little more readily available. Encryption algorithms have to change. So the way we do this, so SSH from 20 years ago is no longer secure because we have systems fast enough that they could conceivably decrypt that data or brute force decrypt that data.
We talked about SCP and SFTP. There was another question in chat that I answered about it as well. So the SCP command stays around.
Yeah.
The difference should be invisible to users, which is the SFTP transfer backend. It's what's used when we're transferring those files between the two machines on either side of the connection.
Yeah.
So we're not getting rid of SCP. We've simply changed how it transfers files to use the SFTP backend, which is a more secure way of transferring the file itself.
That was what I meant to say, but I think I said it in the wrong way. So yes, the protocols in the back end are using, and that was because there were some vulnerabilities that were difficult to fix in SCP, and SCP was an older technology anyway. So SFTP is now here to replace it. We have a link in the description, not in the description yet, but we'll have a link in the notes where we've got a blog about the differences, because there are some very minor differences about shell expansion and whatnot between the two protocols. So those are things you might want to be aware of if you were very dependent on some of the more esoteric use cases for SCP.
All right, Nate, how does SSH work?
I don't have a whiteboard. A quick description is SSH between the client and the server uses a number of different key exchanges to figure out, first of all, you saw that where I had to accept the key when I connected during the critical path, because the host has a key that the SSH daemon is using to encrypt traffic. That's called the host key. And then the host key is used to identify the host. And whenever you go to connect to it, your client has to say, okay, what's your key? It gets the key and it accepts that, and that's the public key of the host, right? If that key ever changes, your client will say, something weird's going on here because I remember this host. I remember what its key, and it's different now. That could mean someone intercepted it or something happened on the server where the key had to be regenerated. Sometimes not malicious, sometimes malicious. But the point is, the SSH client will give you a warning and let you know, hey, that's different. You may want to act on this, right?
And so I just did a quick run through where I connected to a machine for the first time. It asked if I wanted to import the host key. I said yes. When I exited that session, what you can see is in the .ssh directory for my user, there's a file called known hosts. And if I do a, oops, do a cat on that, these are the hosts that I've imported the host side keys for. Um, and the idea behind host keys is that you can validate the identity of the machine that you're connecting to. And the reason that it errors out and says on the when you're SSHing into something and throws an error if that doesn't match is because in theory, someone has taken away the machine you're used to seeing there and put back a machine in its place with its same IP address and host name, which you might not want to connect to and do things on. So it's
Right.
a prevention or a mechanism to prevent either man in the middle attacks where someone substitutes something in between you and your target host, or that there's been a change in the infrastructure without you knowing that there's been a change in the infrastructure.
Right. That's where there could be nasty stuff going on.
Yeah. And on the server side, in the Etsy SSH directory,
Hmm.
these are the host keys created. Nate, when do these host keys get created?
So they get created the first time the daemon starts, as far as I know. I don't think there's any other. You may be able to trigger it otherwise, but when you install the system, it'll generate them. Or, and I was going to mention this after you started talking about the keys. If you build the system and make it a golden image that you're going to use to provision other systems, you need to make sure you nuke these keys in the golden image so that the first boot after you deploy something from that golden image, it makes a new key. Otherwise, you're going to have all of your hosts deployed with the same host key. It's not necessarily bad. It's not going to break anything, but it's bad practice.
Well, it may break things if keys don't match between different machines that you're connecting to, or they're identical to other machines that you've connected to in the
Yeah,
past,
the client may complain about that.
right? There's two sides of these asymmetric keys, right? So what is encrypted with one can be decrypted with the other.
Right.
So what happens is when a client connects, they're going to send a piece of data that is encrypted with this machine's public key. And the only thing that can decrypt that data that's been encrypted with a public key is its matching private key, which is
Right.
not shared inside of this server. And then we're going to put together a response that's encrypted with the private key and send it to the client. And because the client has the matching public key, they can decrypt the challenge and validate it. And so, because both sides transmit data and get back a response with an update that was expected, encrypting it on either side of that connection tells both machines that we have a valid encrypted connection, that our identities have been established, and that we can then establish an encrypted connection with one another. I mentioned keys just a moment ago. I have this regular user on my machine named RHEL, similar to Nate's, and I can SSH to client one. And that's the first time I've connected there, so I'll import the public key. Did I not make the change?
You're trampling my demo. Come on.
Changed it on the wrong server. All right, let's try that again. There we go. All right, so now I'm connected to this remote machine. Everything's good. When we talk about things like some of the other capabilities of SSH, for example, you can do it SSH-C and execute a command remotely.
Hmm.
If I Sorry. SSH. It's been a minute. You know what it is? There's
I don't think
launch.
there's
Sorry.
I
Let's
think you
try
just
this.
put the command. Yeah.
That's what happens when we go off script.
Yeah.
When I made that command, it asked me for the password for that SSH connection to the remote machine, and then it ran the command on the remote machine and then displayed the output locally and then closed the connection. Well, if you're trying to do something like a shell script where you're connecting that remote
Remote
machine
machine.
and you're doing several things, or you need to connect several times to collect several pieces of data, having to type in the password over and over and over again can be really annoying.
Or if it's
Um,
automation, same deal. If that was an Ansible playbook, Ansible will also carry over SSH. You don't want it to ask for a password every time. It's supposed to be non-interactive.
Yeah, and so what we can do is instead of using our password is a authentication token to prove my personal identity, my user identity to the remote system. I can do key-based authentication, the same that we kind of did with the validation of the two machines involved in the connection. So in order to do that, we first have to create a personal SSH key. And there's a command called SSH keygen that will generate this public and private pair key. The default is to store it in my home directories.ssh directory, and it uses an RSA formatted key by default. So it says, I want to create a file named ID underscore RSA. And if you're happy with that, you just hit enter and then it'll create it. Without a passphrase, it stores the keys unencrypted in your local.ssh directory. With a passphrase, you are asked for your passphrase to unencrypt your key before presenting it to the other machine. It stores the key encrypted locally. I now have these two files, the RSA private key, which has been encrypted with that passphrase I put in, and the public key. Now, the other reason you use a passphrase is that if someone were to take your private key, if it was unencrypted and did not have a passphrase assigned to it, they could then present that at different machines and authenticate with that credential. So a passphrase is really a two-factor authentication. You have to have the file, this ID RSA private key file, and you need to have the passphrase to unencrypt it and utilize it. So it's recommended that you use a passphrase when working with SSH keys.
Especially if you're talking about the key on your laptop connecting to your company's core infrastructure, right? Because if your laptop gets lost or stolen and that drive's not encrypted, now someone has your SSH key. And if you didn't have a password on it, they can use it. All they have to do is figure out what you connect to, your username, and they can get all that from the history of that machine, from the SSH known hosts, from your bash command line history. Bad things happen if someone gets that key.
Now we've created these two keys, one private, one public. We need to populate the public key on remote systems we want to interact with. And so we could use SCP and start copying things around, or we can use this other utility called SSH copy ID. And then you tell it what remote host you want to copy it to.
These public keys are text, by the way, folks. So if you absolutely had to, you can copy it to your clipboard and paste it in the right place on the server. Use SSH copy ID, or you can SCP or SFTP the file over and then put it in the right file. There's lots of ways to get this done. But SSH copy ID, or if you had automation, right? If you had some sort of automation set up and you're creating users that way, it can just like echo the public key into the right place. Lots of ways to get this done. But SSH copy ID is a great way to do it in this context.
Yeah. The other place where you'll see keys a lot is if you work with cloud systems. you'll be asked to provide your key so that you can SSH into the cloud system, and there's usually like a just text box that you
Yep.
copy and paste into.
Worse for you today, not
It
for
is.
me.
We could do the ID RSA pub, take this text, copy and paste it into that box, my public SSH key.
More advanced configurations would be like if you had an LDAP directory that you have your users stored in, you can even use that as the source for these keys. IDM is great for that. You can do it with Active Directory. So lots of cool ways to get this done.
So when I used that SSH copy ID command, notice it went over and said, okay, we've added the key to the remote system, and now you can try SSHing. Let's SSH client one. It's asking me for the passphrase so it can unencrypt and use the private key that's stored locally as my authentication mechanism. I put in the passphrase, and it does a key exchange or an exchange of data that similar to the host key, where the remote machine will encrypt a piece of data with the public side of the key. I decrypt with the private key, make a change, encrypt it back, and send it to validate my identity. The SSH copy ID was adding that public key to this file in my user directory on the remote machine called authorized keys. If I just cat it, right? That's the same thing that we saw earlier as the content of my ID RSA pub. So it takes that, sends it to the remote machine, and adds it to an existing authorized keys file on my behalf. But Nate, we mentioned automation.
So basically, what you've done is you've moved the password from the server asking for a password to the key requiring a password. How are we any better now?
If I SSH again, it keeps asking for this passphrase, and exactly like
Right.
any better than before.
There's been some chat about this, so we're about to answer your questions. You guys are predicting the future again.
So there's a utility on the machines called SSH Agent. An SSH agent will allow you to add a key to a in-memory warehouse of SSH keys. So let me start it up. I need to set some local variables in my shell. And basically it's like, this is the SSH agent process ID. This is the socket that we transfer data to and from the SSH agent process on my machine. So these are variables get set in my user environment. Then I'm going to do an SSH add. And it's looking at my key. It's taking my private key and adding it to this warehouse of data in the local machine's memory. And what's going to happen is when I SSH to the remote machine again, instead of being asked for my passphrase, SSH agent is going to intercept that request and provide it on my behalf. So when I SSH to client one, it just happens.
No more
Right?
password.
For anything, it just passed me through. And that's really the SSH agent intercepting the passphrase request and supplying it on my behalf so that we can then do the key exchange and data exchange and identity validation. What's really cool about this is that it is in memory. So if I close this shell, what I've put into the SSH agent vanishes. Every time I create a session, I will have to add my passphrase again into the SSH agent. This happens by default on many graphical environments. So if you've SSH to a machine using a graphical utility, it may have popped up a box that said, please provide your passphrase, and like a graphical
Yep.
utility. And that's the SSH agent operating on your behalf. But what's cool is, remember earlier I like connected to this remote machine and ran a command?
Mm-hmm.
Now it just does it.
Once key authentication is in place and unlocked, you can do path completion using tab on the remote system, which is insane, right? If you did like, I don't know, if you used SCP and you're looking for path and you don't quite remember it and you're used to using tab completion when you're on the local machine, that'll work if it has authentication because it can actually connect to the remote system and say what's that next path and then auto complete it for you on your local shell, which is the first time I saw that work. I'm like, wow, that's really handy.
Yeah. And to tie it off, like if I exit this shell and come back in, it's asking for my passphrase because I closed my session where I had uploaded my passphrase into the agent, which then vacated that information from the agent. And when I created a new shell, I have to re-add my credential into the agent if I want it to persist during this session. So you can just close your session and anything you've loaded in the agent just goes away.
You might be asking, how does that help me? In the automation use case we talked about earlier, you still need this password stored somewhere. Well, in the case of Ansible, for example, there's things called Ansible Vault, or there's a thing called Ansible Vault, or there's lots of other ways that you can integrate third-party tools that use a vault with Ansible. You can store that password in a vault that's encrypted. It'll pull in the SSH key password from there. If all else fails, maybe not the best security, but if you have a sufficiently protected automation server, you could have a key that's not encrypted there. But then just know that if someone gets that key, you're going to have to redo the SSH key authentication on all your systems, and that's not fun.
Aditya Reddy said, can I use the passphrase programmatically so I don't have to provide it every time? SSH Agent is the way to do that. You don't want to put it in your shell script because then you're providing your passphrase in plain
Yeah.
text, storing it somewhere. So Agent, or if you're using something like Ansible, using the Ansible Vault, are the ways that you securely hold on to this data and pass it on your behalf as you're using SSH connections.
Is there a way to seed SSH agent with a stored password somehow?
I've never looked at it either.
I wonder if there's a way to get it done that way. But again, right, you're always going to come down to if there's a password stored, then there's a chance someone can get the stored password. So if you're putting it in a shell script, if you're putting it even in a vault, then you got to worry about how the vault is. Like security, there's always a layer of inconvenience with security. And sometimes you just find the least inconvenient way.
The product manager for security at Red Hat used to always say something like, security is great, but it's always a trade-off between more secure system or system usability. So you always have that trade-off. You can make a really secure system that's impossible to use. So you always have to consider enhancing your security and make your posture better, but without doing it at the cost of usability and making it so that no one actually wants to use your service.
Yeah. Yeah, I used to come to like when you came to the end of the path and the person you're working with those is like it's still inconvenient. Sometimes the answer is security is inconvenient. It's really inconvenient to unlock my front door when I get home after I've been away all day. But it's a lot that inconvenience is worth it so nobody walked into your house and stole your television, right?
Yeah.